All right, how do we pronounce it now that you guys are wise in the ways? Euler's number, yeah. Now, Gavin, I scolded you because you only went this far. 2.718, is that how far you went? And I said, okay, we can memorize it further than that. But you didn't quite give me enough to see the pattern. This is how far I have it memorized. Tell me, and actually a student helped me get there. So probably about 6 years ago, a student was like, Mrs. Yates, we can memorize it further than that. And so I think it's kind of fun. How on earth can I memorize it to however many decimal places that is? You guys see a pattern? What's that? Anyone? There's a pattern.
A lot of 1/8.
Okay, there's a start. You're seeing something.
1/8, 2/8, 1/8.
Okay, there we go. There's an 1828 and an 1828. What about that next part? What do you guys recognize that as? What's that?
There's a 45 and a 45 somewhere there.
And what's in the middle of it?
90.
Okay, so what's special about that?
They add together to be 90. Wow.
What else is special about it? What did you guys learn last year in geometry? Isn't that one of our special triangles? 45, 90, 45? So as long as you can remember this first part, 2.7, and you know 1828, 1828, 45, 90, 45. I actually think Drake had it memorized to who's Drake? The 37th decimal spot. He just took it upon himself to just do it, and it was impressive. It was very, very impressive. Okay, so that is E. Here is the mathematical constant. And this guy right here is ln, also known as the natural logarithm. Natural logarithm. And E and ln go hand in hand. You guys know that logarithms can have different bases. Guess what the base of ln is? Log base E. So today, while we're learning how to use ln, we will probably convert it to log base E every once in a while, just to start making that connection. But you're never going to see that ever outside of us trying to learn it. It will always be written as ln. And I usually write it like that, or I get in trouble thinking it's a 1 times an n or something, something, something. It doesn't have to be cursive, but mine will be. Natural logs follow all of common logarithms, all the other logarithm rules that we already know. So remember, when we add them together, they can be multiplied. When we are subtracting, it's division. All of those rules apply here when we come to solving, and we'll do these step by step. Let's see. Put in log or exponential form. So same thing. What's my base? So log base E of what number? Remember doing this? I know before Christmas was forever ago. Of 23 equals what? X. Are we going to write log base E though? No. What are we really going to write? ln of 23 equals,
so the E just goes away?
Log base E by definition is ln. That's what it is. It is the natural logarithm. Let's do this one. All right. I'm going to write log base what? What's my base in this one? E. So let's save us a little work. Instead of writing log base E and having to rewrite it, what am I going to put instead?
ln.
ln of what number? X equals 4. Now this one is a natural logarithm form. So what do we know its base is? Its base is
Log
e. All right, so e to the what?
X.
Follow that curve. E to the 1.2528 equals x. Let's take a minute while we're right here and find the E button on our calculators. Because we will be doing some evaluating as we start to go through this. If you look, man, I'm going to have to put on my glasses. Here is, right here, we'll zoom in. Here is the ln button. Here is the e to the x button. So if I wanted to evaluate that, e to the 2.528, all I need to do is, let's see, second, gives me that e to the x, and I can type that in, 1.2528. And it gives me a value. So you'll want to know where that is. Questions thus far? It's going to take a little practice, but questions we need to get out of the way? Okay. Write as a single logarithm. I want to smash it into one, like we were doing with LOG before our Christmas break. How do I smash that into one logarithm? What does add mean? Times. I can't do it yet. Why?
Because there's a 4 in front.
Okay, what do I do with that 4? What rule am I going to use?
Make it an exponent.
I'm going to make it an exponent. All right. So now that I have that, I could rewrite this as ln of 3 to the 4th times 6. Is that something we could evaluate with our calculator?
Yeah.
Absolutely. ln, the base is always e. It doesn't change, so you can always, always, always use that ln button. Let's make sure we get the same answer though. Type that in, let's see if we get the same thing. ln of 3 to the 4th. What'd you guys get?
6.186.
I like it. Anyone have questions on how to use their calculator on that? Okay. Which one do I want to do first? Eeny, meeny, miny. Go to, we haven't entered this in. That sounds like we haven't taught you that. We skipped something somewhere. Find that logarithm properties. Did we? Is there a place for it here? Nope, there's not. Quit digging. I thought I left something blank on that, but I didn't. I didn't. All right. So let's talk about something really quick. What if I have log base e of e? What do you know happens? How many e's does it take to get to e? Right? What does this equal? E raised to the what equals e? 1. All right, so this equals 1. Yes? Anytime I have log base e of e, it's 1. So what if I have ln of e? It's still 1. So they kind of cancel each other out, and that's important to know. We need to know that to be able to do these. All right, I want to solve for x. Got a little bit of a mess right there. What do you think we need to do first? As my pen is right here, what are we going to do? Take away the 1. 3 e to the negative 2x equals 6. What do you think we're going to do next? What I want to do is get this alone. I want to get this alone. That's what we're working on. So I'm going to need to divide by 3. Now here, we're stuck because it's brand new. I want to be able to get that exponent back on the ground. What did we use before break to get exponents back on the ground? Remember what we wrote in front? We did. We used logarithm. For sure we used logarithm. But because this equation has e, I want to make sure that I use the natural logarithm. I want it to cancel out. So instead of log, we will use ln. We're going to take the ln of both sides. So what can we do with this exponent right here? They can go to the front. Negative 2x. Just a second ago, we talked about ln of e, that they canceled each other out because they equal what? 1. So by doing that, I ended up with negative 2x equals ln of 2. Is that weird? A little bit. Those canceled each other out. What do you want to do to get the x alone? What are we going to divide by? Negative 2. Now you guys are used to this because we did it. If they ask for the exact answer, that's what you would type in. If they say, give us the answer rounded to the nearest hundredth, what are you going to do? Type it in your calculator and hit enter, right? Would you like to see another problem with e in it before I move to ln? Let me, hate to make them up because I don't want them to be ugly. Let me see if I can find some good ones. 6.1, 6.5. I might have to put on my glasses to see this. All right, find some more. For e to the x minus 11 equals 17. I want to solve for x, which means we want to get that alone. So, what are we going to move first? Add 11, good. 4 e to the x equals 28. What now? Divide by 4. E to the x equals what? 7. I want to get that x back on the ground, so what am I going to use? ln, both sides. So this guy can go in front, and I have x ln of e equals ln of 7. What do you guys know about ln of e? Cancels out. X equals, in this case, I just have the ln of 7. There's my exact answer. If they want a rounded answer, what are you going to do? Type it in your calculator. One more? One more. Okay. Let's see. Find one that's a little harder than that. How about this? 3 e to the 5x plus 1 equals, that's a 5. Okay, you guys were quick at that last time. It made me happy. And I think this is just going to solidify it. We're going to take away 1 and divide by 3. Yes?
Yes.
Can we do that in one step?
Yes.
So we get, yes. We got it. Take away 1, divide by 3. How do you get that exponent back on the ground when we have e? You have to use ln. What do you know about ln of e? Cancels. What do we need to do to get the x alone? Divide by 5. X equals ln of 3 divided by 5. Yes, ma'am.
I just have a question. How would you plug that into the calculator? Would you do ln, then that would get all
So when you type it in your calculator, and that's a good question, just like the log, it opens a parenthesis. So you'll want to say log of 3 and close it, and then divide it by 5. Or else you would have the log of 3/5 if you didn't close the parenthesis. Good question. Okay, let's see if we can make this one easy too. Oh. Anybody have any ideas? When we had one logarithm in the past, we were stuck. We're stuck. And so we had to convert it. We had to convert it to what form?
exponential.
Exponential form. Yes.
I don't know where that came from.
Because you're right. You're totally right. You're like on it today. So I want to convert this to exponential form. ln, you need to remember, is really what? Log base what? E. So we can do this whole little thing again. All right, this is going to be kind of ugly. Ooh, can we make it prettier? Oh, I've got to tell you guys a secret before we do that. It'll make it so much easier. See this square right here?
Yeah.
If I leave it there, I'm going to end up with something like this in a minute. And this is going to turn into a really big quadratic question quickly. Now this is one of those little tricks that if you don't see it, you don't see it. And you have to do it the long way. And then I'll just cry a few tears for you. But we'll get over it. So you guys know exponent rules. As long as I have a logarithm in front, can't that be written right there?
Yeah.
Okay. Now I want to get this alone. So what could I do? Divide both sides by 2. So that's going to leave us with ln of 3x plus 1 equals 4. Now let's do it. What's my base? What's the base? Log base what is ln? I want to hear everybody say it. You should know. E. E raised to the 4th equals, are we lost? Did I hear lost? All right, we're okay. E to the x equals, e to the 4, equals 3x plus 1. We used our calculator a little bit ago, right? Is this something we can figure out the value of?
Yeah.
Yeah. So if it wants a rounded answer right now, I would stop and figure out what e to the 4th is. Maybe let's do that. Let's go that route. E to the 4th. Something like this. 54.5982 equals 3x plus 1. It's ugly, but how are you going to solve for x? What are we going to do? Minus 1 divided by 3. All right, I'm just going to do it. Minus 1 divided by 3, and I get 17.87. Would you like another ln problem before you're on your own? All right, we'll do it. Let's see. All this beautiful scratch paper back here. That's too easy. Too easy. Let's find a harder one. Just what you want to hear, huh? Let's find a harder one. I don't know how hard it is, but it's better than what I had a second ago. Ooh, let's not put 36. Let's make that much, much, much smaller. Let's put 9.8. Okay, I have one logarithm. Whenever you have one logarithm, you're stuck. You know that you need to convert it to exponential form. So what's your base? E. Raised to the what? 9.8 equals x plus 4. You're going to grab your calculator. You're going to figure out what e to the 9.8 is. And then what are we going to do? Take away 4. And I get a really big number. Oh, I did 10 raised to the 9.8. No wonder that didn't work. Goodness. E raised to the 9.8. There we go. Take away 4. And I got 18029.7-ish. Does that sound right? Did anybody calculate it? Waiting on me? Okay, perfect. I do want to point out on this problem over here, what would happen if you didn't see the secret shortcut?
You'd have to FOIL.
We would end up having to use the quadratic formula on that FOIL problem. You're going to get 2 answers. Guess what you would have to do with both answers? You have to plug them both back in to check them. One of them would be good, one of them would be bad. So, let me know when you get stuck. Don't spin in circles on this one. Okay, let me help you through it. Sorry?
That, it will always work good.
Yeah, I like natural logarithm. I'll write it more than LOG all the time because it works with E, it works with any other problem as well. You can always move that exponent back to the ground. You're out of data?
Yeah.
You think you